What did you find? How many different angle measurements did you have in this particular experience? There are only 2 different angle measures, which gives me really good news to pass on to you. From now on, when we are done with this lesson, if you know you have 2 parallel lines cut by a transversal, we have now cut your work down to having to measure 1 and only 1 angle, and you get to know the rest of them from there. This is, so let's get our angle measure. Measure angle 1 has a degree of 40 degrees. Ooh, again, within 2 degrees is fine. 2 has then
140.
140 degrees.
Because they are.
They have to
180
minus 40.
Thank you, Mr. Monty. These 2 angles, 1 and 2, create an angle measure of 180 degrees. Those are supplementary angles. Okay? I also then know which one.
Oh, 4 and 3.
Okay, I know 3 is
40.
40 for what 2 reasons?
Because they are
It's,
supplementary with 140
Okay.
degrees.
3 is
Thanks,
supplementary to angle 2. Therefore, that has to be 40. It is also angle 3 is besides supplementary, vertical to angle 1, and therefore these 2 have to match. And then again, I know that 4 has to
140
be
degrees.
140 degrees for the same 2 reasons. Now, ladies and gentlemen, this line is parallel to this line. Yes, it says so in our directions.
Yes, ma'am.
What rigid transformation occurs in order to get 2 parallel lines? Very good. It's a translation. This line is simply a translated line of this line. It is slid by a
What's the day?
vector,
Vector.
okay, along the transversal at the exact same rate of change. Because the 2 lines are parallel and are cut by 1 line, the rate of change in this line is the same as the rate of change in this line. This line is a straight line between both of them. Therefore, angle 5 has to be
40 degrees.
40 degrees because of what relationship from up here?
Because it's the same translation down on the vector, and yeah.
Right?
Exterior. So
You just
Not,
explained
it is not, angle 5 is
Interior.
an interior angle.
Interior.
It is an angle 5 is and angle 3 are alternate interior angles. Okay, of a transversal cutting parallel lines. Therefore, angle 5 and angle 3 have the same degree of measure.
basically.
What other relationship does angle have 5 with a? What other relationship does angle 5 have with a different angle that makes it also the same?
Angle 3.
I already said angle 3. It's an
Angle
alternate
1.
Angle
1.
6.
What relationship does angle 1 and angle 5 have to one another?
They're the same.
They are alternate.
Thank you very much, Mr. Merriam. These 2 are corresponding angles. Okay? As the same as your alternate interior angles have to be the same when a transversal is cutting parallel lines, your corresponding angles also have to be the same. What other angle has the same degree of measure?
Ooh.
Yes.
3, 2, and 6.
Okay? 2 and 6. Angle 2 has a degree measure of 140. Therefore, angle 6 has to have a degree measure of 140. First of all, it's supplementary to angle 5. It is corresponding to angle 2. It is an alternate interior angle to angle 4. Any other relationship that we see right now? All right. What other angle do we know here?
8 and 3.
Angle 8. Angle 8 has to be
140.
140 degrees.
Degrees, yeah.
It is a vertical angle with angle 6. It is supplementary angle with angle 5. It is an alternate exterior angle with angle 2, outside angle, outside angle. It is corresponding with angle 4. All these relationships exist.
Angle 7 is 40.
And 7 would have to be 40
Degrees.
degrees. So the nice thing is when you see a set of parallel lines being cut by a transversal, really and truly you can get away with one angle degree of measure, and then you have a whole lot of information as long as you understand that you will end up with equal degree of measures for the different relationships that exist. Are there any questions on this? Yes, sir.
You have to write the, like, triangle one and, like, you have to write all the.
I was just writing these down as examples. We have to answer the questions that are asked. We go to question letter A. What did you notice about the measure of angle 1 and angle 5?
Alternate.
Corresponding.
They're alternate.
Okay, let's ask that question again. What do you notice about the measure of angle 1 and angle 5?
They're the same.
They are the same.
I said
Okay,
that.
angle 1 and angle 5 both have a degree to measure of 40. Why do you think this is so? We know it's so because these two lines are parallel. It is slit at the exact same rate of change. Therefore, they have a relationship of corresponding angles. 3 and 7, okay, those two are the same. Again, corresponding, parallel lines, same rate of change. Come on down. What do you notice about 4 and 6?
They're the same.
4 and 6 have the same degree of measure. These two are what relationship to one another? Alternate interior angles. They are inside the parallel lines. So now we go and we have the main ideas out of this chapter. What you need to know by the time you finish this. Number 1, angles that are on the same side of the transversal in corresponding positions are called corresponding angles and will have same angle measures if the two lines are what? Parallel. If they're not parallel, like in example number 1, do you have the same degree of measure? Oh, I erased them. If the two lines are not parallel, do you get the same degree of measure?
No.
No, those relationships exist in those, however, they don't have the same degree of measure. It goes over alternate interior angles, angles on opposite sides of the transversal to the inside of line 1 and line 2 are alternate interior. When they're on the outside, it is alternate exterior. And when parallel are cut by the transversal, any corresponding angles, any alternate interior angles, and any alternate exterior angles are equal in measure. This right here is the main idea. Your assignment is going to be to answer the problem set at the end of lesson 12. Due tomorrow.